How do large language models actually work? Say I have a question about who wrote the book Rabbit Run. I typically feed this into an LLM, such as ChatGPT, Gemini, or Claude, and I would get my answer back of John Updike. But what actually happens in this middle step? A large language model is made up of a number of components, but it can be easily split up into three distinct sections. A pre-processing stage, where the text is prepared and transformed from text to numerical vectors that the LLM can understand. A processing stage, where the model interprets the input and forms an internal representation of its meaning. And finally, a post-processing stage, where the model prepares its output for the user back from vectors to text. In the first part of our video, we took a look at the pre-processing stage, where we converted our input text into relative vector representations. We now take these embedded vector representations of our input and feed them through n-many transformer blocks in our processing stage. More specifically, we start with our input vectors, which represent our input text. We then feed them through our transformer blocks to get context-aware vectors as our outputs, where these are internal representations of each word's meaning and its contextual information within the input sequence. More specifically, these transformer blocks take isolated input vectors from our first stage and enrich them with information from the rest of the sequence. Let's consider our sequence of words in our input, and let's specifically focus on the word book. We got from our first stage an embedded vector representation of this word, which encapsulates its meaning and position within the sequence. However, what the vector does not contain is any information regarding other words in the sequence. That is, this vector representation of book does not contain any information regarding its context, dependencies, relevance, nuance, or intent. All of these things are crucial when a human reads and understands a sentence. For example, knowing the context surrounding the word book in the sequence lets the model know that this isn't a book in general, but that it belongs to a specific phrase where without Rabbit Run, the model would not know which book the question refers to. This information allows the model to answer questions with respect to inputs such as which book, what is the question asking for, and what type of answer is expected. To incorporate this information, we inject the representation of a given word with contextual information from other words in the sequence. So we take our input vector for our word and process it through our transformer blocks to bake in this information and provide us updated vector representations that encapsulate this contextual data, which is why we call our output vectors contextualized vector representations. We then do this for each word in our sequence, injecting relevant contextual information from other words to give us an updated vector representation. As such, we exit our transformer block with an updated set of context-aware vectors. In the next stage, we pass our context-aware vectors through our output layer to get our final answer.